In this case, we are going to discuss how to scheduling employees in the company of Air Express. In this case, the manager of the Air Express hub in Baltimore, Maryland, is concerned about the labor cost at the hub, and they are interested in determining the most effective way to schedule workers. The current situation is the hub operates 7 days a week, and the number of the packages handled every day varies from one day to the other. So based on the historical data, we can estimate the number of the workers needed to handle the packages. And because some employees have to work in the weekends, so the salary will be slightly higher in the weekends for those who work only in the weekdays. And the difference of that will be $25 per day for those people working in the weekends. Based on that information, we can have the following tables. On the left-hand side, we have the information about the number of the workers needed for every single day. For example, we need 18 workers for Sunday. For Monday, we need 27 workers, and so on. We also have those salary information for every shift. Currently, we assume if those workers coming in, they're going to work for 5 days continuously. For example, for shift 1, those employees will take a day off on Sunday and Monday. In other words, they're going to come in from Tuesday, Wednesday, until Saturday. The salary for the shift 1 will be $680. For the shift 2, they're going to take days off on Monday and Tuesday. So they're going to coming in from Wednesday, Thursday, until Sunday. Because they work in both weekends, so the salary will be higher, and then it is $705. Similarly, for shift 3, they'll take days on Tuesday and Wednesday, so they continue to work from Thursday, Friday, until Monday. The salary for that will be $705 as well. So we have all those salary information for every single shift. Our concern is how to solve this problem using integer programming. We know that we cannot divide the employees into half. So we have to specify integer conditions for those numbers of the employees. Now let's try to define the decision variables at first. We can definitely define x1 as the number of the workers assigned to shift 1. X2 will be the number of the workers assigned to shift 2, and so on. We can also just use xi equal to the number of the workers assigned to shift I. And actually, when we have many decision variables, the xi equal to number of the workers assigned to shift I will be preferred. Now let's try to describe the relationship between those 7 shifts and 7 days that employees must come in. We have 7 shifts. Shifts 1, 2, 3, 4, 5, 6, 7. We have 7 days: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. For shift 1, they take days off on Sunday and Monday, but they must come in from Tuesday, Wednesday, until Saturday. For shift 2, they must come in on Sunday, and they take days off on Monday and Tuesday, and they come in on Wednesday, Thursday, Friday, and Saturday. So after we fill in all those information for all 7 shifts, we have this relation table. Based on this relation table, we know that the number of the employee coming in on Sunday must be larger or equal 18, right? And we can specify that in the LP model. Now, based on the relation table information, we can construct the integer programming model. First, on the objective function, the target of the company is to minimize the total wage expense. So the objective function can be expressed as minimize 680 times x1, and that is the salary cost for those employees coming in shift 1, plus 705 times x2, and we summed all those costs of the salary for every single shift from x1 to x7. That's the total salaries for all 7 shifts. For the constraints, we know that for those employees coming in Sunday must be more than 18 employees. So we require that shift 1, shift 2, shift 3, shift 4, shift 5, shift 6, and shift 7 employees altogether must be larger or equal 18. But we know that for shift 1 and shift 7, they don't need to come in on Sunday. So we still need to sum up from shift 2 to shift 6 and make sure the total will be larger or equal 18. Similarly, for Monday, because shift 1 and shift 2 employees do not come in on Monday, we need to sum up from shift 3, 4, 5, 6, and 7 together must be larger or equal 27. We can do the same thing for all the rest of the days, so we have all these constraints. So far, we still have only linear programming without integer conditions. Because we cannot divide employees into half of 0.3, something like that, we must specify that all xi must be integer as well, in addition to the non-negative constraints. And after we have this LP model with the integer constraints, we can input into the Excel solver and solve this problem. Thank you.